Hi, in this video, I'm going to talk about an motion and define the average speed, and instantaneous speed. So describe the motion. It is useful to know how fast things are moving, and the measurement of how fast the object is moving is we use a physical quantity that's called speed. So in the physics, we use a lot of quantity that we can measure. And we need to define what we were seeing. And here's the definition of speed. Okay. Here. So define the speed. So speed describes how fast to measure and describes how fast things are moving. How fast or how slow. So it's just to show how fast things are moving. That's what the speed is. And how to find the speed, that's equals to distance divided by time. Distance you can measure in meter, time you measure in second typically. So distance describes how much it traveled divided by how long it took to travel that distance. And the scientific notation, distance we use meter and time we use second for scientific notation for unit, what we measure. Therefore, speed, the unit for the speed is meter per second. Meter per second is the unit for the speed. Since the speed describes how fast things are going, it does not have information about the direction. It's just showing that, it just shows that how fast or how slow things are moving. So the speed is, speed is a scalar quantity. This is the definition of a speed. When you hear that a speed, okay, it travels whatever the distance and then how long it took to travel that distance, right? But it depends on how we say, okay, are we saying the time period from here to here or there to there? So speed, we can say there's an average speed and instantaneous speed. So there's an average speed and there's an instantaneous speed. Average speed is the speed that's average. So let's see, I'm just going to first write down definition of average speed. Let's use the V average or speed. I should say speed. Average speed, I'll just write average speed. That's equals to, so to find the average speed, you're going to look at the distance traveled, right? So you say, you find the distance that you're interested in to find. So you want to look at from the point A to point B and how fast it moved from point A to point B and find the average. Then the distance from point A to point B divided by how long it took to travel the distance from point A to point B is the average speed. So again, the distance we typically measure in meters and the time we typically measure in seconds. Therefore, the unit for the average speed is again meter per second, and also it's still scalar. Okay, this is still scalar. It's just to show how fast it's moving. It doesn't have any directional information. Instantaneous speed, on the other hand, describes the speed at that time. Speed at that moment. Okay. Let's go back to the average speed. So when we talk about the average speed, the distance traveled from point A to point B and how long it took, right? So it does not have information about the variance in speed. To get from point A to point B, we don't know. Maybe you're stuck in a traffic in the middle, so you slow down, or even you're caught with the red light, so you stop. Then you start going fast, then go, stop again. So there could be a variance in speed from point A to point B, but when we discuss the average speed that we got to the location point B from point A, and talk about average speed, it doesn't have any information. We don't know, you speed up for this much seconds, you went constant speed for this much. We don't know anything. All we know is the average speed from point A to point B, how fast you moved. So the average speed doesn't have no information about variance in speed. It could be, you could be moving constant motion throughout, or you could move fast for a while, then stop for an hour. We can't tell. Tell from average speed. This one doesn't contain that information. Instantaneous speed, on the other hand, is to describe the speed at that moment. So this is, so let's say police, when you're driving and then they measure, they say, oh, you're speeding with this speed. But what he measured at that moment to say how fast you're going is at that time, he's discussing about your instant speed, right? So it's not that how long it took you to come to that point. It's about speed at that moment. So the instantaneous speed is the speed at that time. And also, so it's something like a speedometer measures. When you're driving, your speedometer tells you how fast you're moving at that time. And also, we use meter per second to measure the instantaneous speed. Any speed we measure, we use the meter per second typically. Meter per second, meter per second. To find the value of instantaneous speed, we have to use calculus, but we pretty much make that this time period that we mentioned for average speed, we make this time period to be very, 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 very short. That is almost instantaneous. So you find that to be tangent to the curve, tangent to your path. Okay, so that's how you can find it, but we need to use calculus. All right, so that's average speed and instantaneous speed. Example, maybe I'm going to use this one here. Okay. Smaller. So here's a car. The girl is driving on a truck doing wheelie. So let's say this is the path of her truck. She's going this way now. Maybe she's gonna came from this way. This is the path she's taking. So overall distance, let's say, is 20 meters. Okay. And it took her 10 seconds to travel 20 meters. Then average speed of her doing a wheelie is equals to 20 meters divided by 10 seconds. So that's equals to 2 meters per second. But we don't know that maybe in the middle. So right now, maybe she's at this point, maybe instantaneous speed at that time, it can be actually 5 meters per second. And then maybe over here, she might have stopped for a while. But overall, she traveled 20 meters in 10 seconds. So something like that. That's the difference between the average speed and the instantaneous speed. I'm going to ask you this question. And I'm not going to show you finish up the video. All I want you to do is to think about this setup. And I will ask you this question in the class. So here you see two trucks. The one in front has a little dent. So they, we're gonna put he's gonna put the ball starting from the same location, same height. And then the ball is gonna be released exactly at the same time. The ball, the truck behind goes down and then it goes onto the rather flat surface. The truck front of it goes down on the same amount and it goes on the flat surface together, but then it goes down to another dent and then travels for a while and come back up and come back onto the same flat surface. Which ball that travels either in the front or the back, which one is going to get to the end first? Which one is going to get to the end first? Is that the one in front or is that the one in the back? And we'll discuss this in a class. Let me go back and then I'm gonna draw that figure. And this video there. Okay, so one truck goes down. So let's call this track A. The other one goes down on doesn't look similar. It goes down on a similar slope like that. And then like this, but it goes down again and travel for a little while, come back up, and then come back. Okay, so that's B. You put a ball from the same location and travels. Which ball reach the goal first? And why? All right, so we'll discuss this in the class. This is the end of this video, and I see you in the class.